A quadratic function can be used to model or analyze real-life situation. One example of this is that it could be used to describe projectile. A projectile is any object thrown by the exertion of a force. For example, when the cannon is launched, there is a force exerted on the projectile which propels it some distance away and some height will change in time. A function can describe how the height changes with respect to time. A quadratic function or expression is one in which the highest power of x is squared followed by x to the first followed by x to the 0, which could be rewritten or simplified into ax squared plus bx plus c. C because x to the 0 is 1. There are several ways to solve these expressions. The first method is factorization if it is factorizable. The second is completing the square, which is the vortex form. And the other method is the formula method. Given the quadratic function x squared minus 6x plus 5, solve, find the axis of symmetry, and find the maximum or minimum point. We will solve the expression by factorization. In order to solve this expression, we need to equate it to 0. So I would get 0 is equal to x squared minus 6x plus 5. So I could label my terms. Then I have my a term, which is 1, my b term minus 6, and my c term is 5. So the next step is to find two factors, which when multiply give me the product of a and c. The product of a and c is 1 times 5 would give me 5. And at the same time, I need these two factors when add sum to give me b. In this case, my b term is equal to minus 6. So two factors when multiply give me 5 and when add give me minus 6 would be minus 1 and minus 5. Now I will substitute back these two factors into the expression, which would give me 0 is equal to x squared minus 1x. You could just write x and minus 5x plus 5. Now if I sum minus 1 and minus 5, I'd get back minus 6. So now I could factorize. I factorize the first two terms. I'd get x into x minus 1 minus 5 into x minus 1. Now the two brackets are the same, so I must ensure that the two brackets are the same. Now I could pair them. I have x minus 5 and x minus 1. In order to solve, I must equate both brackets to 0. So x minus 5 into x minus 1 is equal to 0. Now I equate both individually to 0. Now this would give me x, or I'll call it x1 is equal to 5 and x2 is equal to 1. Now these would represent the two roots of the equation. Before I solve for the axis of symmetry, let's get an intuition behind what is the axis of symmetry. The axis of symmetry is a line which separates both sides of an object equally. For instance, take this triangle I'm drawing. The vertical line separates both sides equally, and the point here is the point which the axis of symmetry lies. Take this piece of paper for instance. That crease would represent the axis of symmetry because at that crease this paper would fold equally. The axis of symmetry mathematically is the sum of the two roots divided by 2, or the midpoint between the two roots. In this case, I would have 1 plus 5 divided by 2, which would give me 6 divided by 2, and that would give me 3. The maximum or minimum value is that value which occur at the axis of symmetry, or that value of y which is yielded by the axis of symmetry. So take the expression for example. I have the axis of symmetry being equal to 3. So I could substitute 3 into this equation, and that would give me 9 minus 18 plus 5. That would give me 9 minus 13, which would now give me minus 4. Having computed the necessary values, we now could sketch a rough graph of what this function would represent graphically. We found that the two roots of the equation is 1 and 5, and the axis of symmetry is 3. And at 3, we yield a value of minus 4. Now this would give us a minimum point with coordinate 3 and minus 4. Our C value is 5. C is that value which cut the y-axis. So we start at 5 and I go straight to the minimum point, intersecting the two roots, and this would give me what my expression represent.